Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. AIP Sahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a pipe which is in the form of a frustum of a cone having height of the frustum of cone equal to 35 millimeter. So here we can check the height of the frustum of the cone happens to be 35 millimeter and the diameter of the base of the cone happens to be 40 millimeter, while the diameter of the top face of the frustum of the cone happens to be 16 millimeter. Now this pipe has got a side opening made by a section plane perpendicular to the VP and inclined to horizontal plane at an angle of 60 degree over here. And this side opening, it passes through the center of the base ring. So here we have got intersection of this cone by an auxiliary inclined plane, that is inclined at an angle of 60 degree with respect to horizontal plane and perpendicular to the vertical plane. And this auxiliary inclined plane or the opening in the pipe, it is going to pass through the center of this particular cone over here through the base of the rim. Now with this information we are required to obtain the development of lateral surface of the truncated cone as shown in the figure over here. Now let us proceed with evaluation of orthographic top view and front view projections corresponding to this truncated cone or the pipe which is available in the form of a frustum of a cone. So here when the observer is going to look at this cone or the pipe from the top, we are going to obtain the circular projections corresponding to the base of this cone onto the horizontal plane. So we know that the base of the cone, it happens to be 40 millimeter diameter. So we have drawn the circular projection with diameter equal to 40 millimeter onto the horizontal plane in the top view projections over here. So now we have divided this circular projection into 12 equal parts over here so that the included angle for each one of these 12 sectors, it will be equal to 30 degree. So all the 12 points of the base, they have been appropriately marked into the top view projections over here. And we have also obtained the access point, that is the apex point over here. Now the apex point happens to be point O over here. Now having obtained the top view projections corresponding to this cone, now let us obtain the front view elevation projections corresponding to this cone over here. Here 12 points of the base, they will be projected onto the XY reference line as we are going to draw projectors through all the 12 points onto the XY reference line over here. So this way 12 points of the base we have obtained onto the XY reference line into the elevation projection view over here. Now we also know that the height of the frustum of the cone happens to be 35 millimeter. And another information we have, at a height of 35 millimeter, we are going to obtain the top face or the top circular projection corresponding to the frustum of the cone over here. So now we are going to obtain that at a height of 35 millimeter. So once we mark 2 points over here, 8 millimeter on either side of the axis, so that the top face of this pipe or the frustum of the cone, it should be having diameter is equal to 16 millimeter. Now once we obtain these 2 points, now we can join this point that is corresponding to the top of the frustum with 1 dash. Similarly this point we can join with the point 7 dash of the base corresponding to this cone over here. So having joined these 2 edges over here, now we have to complete the construction of the cone. So we are going to extend this portion over here. Similarly this projector line or this slant generator will be completed as we extend it, so that both of these slant generators, they meet at the apex point over here, which happens to be O dash. So this way we have been able to obtain the front view projections of the cone over here. So now as we obtain the apex point O dash into the elevation projection view, now we can join point O dash with all the other 10 points of the base over here into the elevation projection view. So O dash 1 dash and O dash 7 dash we had joined earlier. Now the remaining 10 slant generators we have been able to obtain as we join apex point with the 10 points of the base into the elevation projection view. So now we can see that here we have got top view projection corresponding to the frustum of the cone over here. It is going to measure 16 millimeter circular projection over here. So if we are going to look at this frustum top face from the top, so now once we draw two perpendicular projectors into the top view projection over here, now we are going to obtain the circular projections corresponding to the top face of the frustum of the cone obtained into the plan projection view over here. Now we know that the apparent length of the slant generator O1 and the apparent length corresponding to the slant generator O7. So both of these apparent lengths O1 and O7, they happen to be parallel to the vertical plane. So in the front view projections, O-1- and O-7- slant generators, as they are represented in the elevation projection view, they will be depicting the true length of the slant generator corresponding to this cone. Whereas the remaining 10 slant generators that we have corresponding to 212, 311, 410, 59 and 68, they will be representing the apparent length projections of the slant generators into the elevation projection view. So now we have been provided with the information. There is an auxiliary inclined plane or an opening which is there, which is starting from the center of the rim over here, and this opening or auxiliary inclined plane, this will be inclined at an angle of 60 degree with respect to the horizontal plane, and it will be perpendicular to the vertical plane over here. And now we can join the remaining portion of the solid. So this portion of the solid was already cut because it was the frustum of the cone. This portion of the solid has been removed because it has been intersected by an auxiliary inclined plane, or it has been removed to provide the opening into this pipe over here. So now we have been able to obtain the front view projections of this truncated solid over here. Now total of 7 points of intersection, they will be available by virtue of intersection of this cutting plane with base points and the slant generators of this particular cone. So we can check this AIP or the cutting plane. It is going to intersect with 2 points of the base, that is 4 dash and 10 dash over here. So the points of intersection, they can be labeled as 4-1 dash and 10-1 dash respectively onto the base of this cone over here. Now next 2 points of intersection, they happen to lie onto the slant generators O-5 dash and O-9 dash, which are overlapping with each other into the front view projections over here. So now onto the apparent length of the slant generator O-5 dash, the point of intersection which will be obtained by intersection of the AIP with the slant generator of the cone, it will be 5-1 dash. Similarly 9-1 dash point, it is obtained over here by virtue of intersection of the cutting plane with the apparent length of the slant generator O-9 dash over here. Similarly, at this point, we are going to obtain point 6-1 dash. So 6-1 dash point is obtained onto the apparent length of the slant generator O-6 dash over here by virtue of its intersection with the cutting plane. Similarly, 8-1 dash, it is the point of intersection which is obtained onto the apparent length of the slant generator O-8 dash over here. And the last point of intersection happens to be 0.71 dash. So 0.71 dash, it appears onto the true length of the slant generator O-7 dash. And now once we have located these 7 points of intersection, let us proceed with evaluation of development of lateral surface of the uncut cone over here. So now we know that here we have got point O dash. So this slant generator O-1 dash and O-7 dash, they are going to represent true length corresponding to the slant generators of this particular cone over here. So once we measure this true length, now with O as the center, 1 as the starting point, now the radius that we are going to pick up over here. So this true length of the radius of the slant edge will be O-1 dash and O-7 dash over here, and both of them, they are equal to each other. So now with this radius O-1 dash or O-7 dash, we are going to draw an arc over here. So once we draw an arc over here, so through point 1, so we know that we have divided the base of this cone into 12 equal parts or 12 equal sectors over here, each measuring 30 degree. So now the distance between points 1 and 2 will be same as distance between the points 2 and 3, 3 and 4, and so on. So now once we measure this sector length over here, 1 to 2 distance. So once we measure this distance between points 1 and 2, so 12 arcs we are going to mark alongside this particular arc which we had marked, corresponding to the true length of the slant generator over here, which was O-1 dash or O-7 dash over here. So 12 arcs which are equidistant, corresponding to the 12 sectors of this cone, they have been evaluated over here. So now we can join this apex point with all the points of the base as they are obtained into the developed surface area over here. So this is the development of the uncut cone that we have drawn over here. So now we know that the first 2 points of intersection, they happen to lie onto the base and they will be coinciding with the points 4 dash and 10 dash respectively. So the first 2 points of intersection onto the base, they happen to be 4-1 dash and 10-1 dash. So wherever the cone will be cut onto the base by the cutting plane over here, so this point will be labeled as point 4-1. So point 4-1 and 4, they will be overlapping with each other. Similarly, wherever the cone will be cut at the base by the cutting plane at the point 10, so point 10-1 will be obtained onto the base over here. So points 10 and 10-1, they are again going to coincide with each other. So into the development surface view, we have marked the points 4-1 and 10-1 corresponding to the base of this particular cone. And point 4 and 4-1, they will be coinciding. Points 10 and 10-1, they will be coinciding. Now the next 2 points which we have with us, they are 5-1 dash and 9-1 dash. So 5-1 dash and 9-1 dash, these 2 points, they happen to lie onto the apparent lengths of the slant generators O-5 dash and O-9 dash. So this distance O-51 dash and O-91 dash distances, they will represent the apparent length of the radii over here. So we need to convert these apparent lengths of the radii into the true length of the radii. So what we can do, from points 5-1 dash and 9-1 dash, we have drawn a horizontal projector line so that it intersects with the true length of the slant generator, that is O-1 dash over here. So now this radius which we have obtained by virtue of transformation of this apparent length into the true length over here, so this radius will become O-52 dash and O-92 dash. So therefore onto the 2 generators O5 and O9, so the same distance we are going to mark over here. That is, if we mark the same distance over here, we are going to obtain the point 5-2, and if we mark the same distance over here, we are going to obtain the point 9-2 over here onto the slant generator true length O9 over here. So the 2 points of intersection we have been able to obtain over here. Now the next 2 points of intersection, they happen to be 61 dash and 81 dash, as they are obtained onto these apparent length of the slant generators O-6 dash and O-8 dash, as this slant generator has been intersected by the cutting plane over here. But again, the radii which we have obtained by virtue of this intersection, that is O-61 dash and O-81 dash. So these radii will represent the apparent length radii. So now from point 61 dash and 81 dash, again a horizontal projector line has been drawn onto the true length of the slant generator O-1 dash over here. So this way, this apparent length radii has been transformed into true length radii. And how much will be the distance of the true length radii? This will be equal to O-62 dash and O-82 dash. So now we need to transfer this distance O-62 dash and O-82 dash onto the true length of the slant generators O6 and O8. So onto O6 and O8, if we mark the same distances, so the 2 points 62 and 82 will be obtained over here. Now the last point of intersection, it happens to be point 71 dash. So point 71 dash happens to lie onto the slant generator O-7 dash, which happens to be true length. So onto this true length O-7 dash, the point of intersection of the cutting plane with this slant generator, it is 71 dash. Now this radius O-71 dash happens to be true length. Why? Because it is already obtained onto the true length of the slant generator O-7 dash over here. So we will be measuring the same distance O-71 dash over here. Now onto the true length of the slant generator O7, will mark the same distance over here. So the 0.71 will be obtained onto the lateral surface development view. So all the points of intersection we have been able to obtain over here. So now we can join all these points with the help of a curve. So now the development of the intersection of the cone by this AIP has been obtained over here. Now let us obtain the development of the cone corresponding to this frustum over here. So we can see as this AIP, so frustum means another AIP parallel to the horizontal plane has intersected with this cone over here. So we know that corresponding to this particular intersection of the AIP, which yields us with the frustum of this cone over here having top face 16 millimeter and height is equal to 35 millimeter. So one thing is clear, that this AIP, it has intersected with all the 12 slant generators of this particular cone over here. So again 12 points of intersection we have obtained, but we haven't marked all those points. Why? Now we will observe that this auxiliary inclined plane has intersected with true length of the slant edge O-7 dash at the point 72 dash over here. And similarly, this auxiliary inclined plane corresponding to the frustum of this cone, this has intersected with the true length of the slant generator O-1 dash at the point 12 dash over here. So now we can check this radius O-12 dash, it is the true length radius. O-72 dash, it is also the true length radius. Now corresponding to the remainder 10 points, so 10 apparent length radii we will be generating over here. Now the true length of the points of intersection, they will be projected either onto the true length over here, that is alongside 12 dash, or they can be projected alongside the 0.72 dash over here. So whatever may be the number of points over here, that is 10 number of points they exist corresponding to intersection of the auxiliary inclined plane corresponding to the frustum of the cone and with the respective apparent lengths of the generators over here. But all of those points of intersections, they will be converging with either 12 dash or they will be converging with 72 dash. So only one radii we are going to obtain, it can be either O-12- or it can be either O-72-. So now since we are starting the development from O1, so onto the true length of the generator O1, now we will open the arc having the same radius. What will be this radius? This radius will be equal to O-12- over here, which will be equal to O-72-. So whatever other 10 points of intersection they are available onto the intermediate slant generators over here, they will be converging with the points 12- or 72- over here. So that is why, since the radii, they are not going to be different for the intermediate points as well. So we have marked only the boundary points over here rather than marking all the points, because distances for all the other 10 points of intersection, they will be the same. So what we are going to do over here, with O as the center, corresponding to this frustum, will mark the true length of the radius over here. So this radius we are going to draw corresponding to all points of intersections with the intermediate slant generators over here, starting from point 2 up to point 12 over here. So this way, a simple arc is going to describe points of intersection of this auxiliary inclined plane, which is going to generate the frustum of the cone over here. So this way, corresponding to the frustum of the cone, so this is the development, and now we can join points 1, 2 and point 1 over here on either side, and we can join this portion of the curve onto the base and this portion of the curve onto the base. Now we can observe this segment, this semicircle onto the base has not been intersected by this auxiliary inclined plane over here. So that is why, so this portion 1, 2, 3, 4, 10, 11, 12 and 1. So 1, 2, 3, 4, 10, 11, 12 and 1. So this portion, it remains as the uncut portion of the base of this cone over here. So with this, we have discussed the evaluation of front view projections as well as the top view projections corresponding to this truncated cone, and we have been able to develop the lateral surface of this truncated cone, which has been cut by two cutting planes over here. So one cutting plane happens to be auxiliary inclined plane, which is inclined at an angle of 60 degree with respect to the base and passing through the center of the base rim over here. Whereas the second cutting plane, it is going to cut the cone parallel to the horizontal plane, so that we should be able to obtain the frustum of the cone, in which the top circular projection happens to be 16 millimeter, the base of the cone happens to be equal to 40 millimeter, and the height of this frustum of the cone happens to be 35 millimeter. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of development of lateral surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.